Okay, so which way you prefer? It can be done in two ways. Okay, so if you want to do implicit derivation, you can do start right away, derive without using the F scenario. Either you do implicit derivation, both would be implicit, okay? Implicit derivation right away, or you can do it through F. Now you can name fxyz function by collecting all to one side. Okay, it can be yz plus x ln y. So if I want to do it in the first way, so this is the first method. Okay, go ahead. So derive z with respect to x. You want to derive z with respect to x.
Yep.
Okay, so z and x would be considered as variables. Y right here is a constant. You want
Right.
to derive z with respect to x, so this would be y. Okay, times the derivative of z with respect to x. You agree? The derivative of the z is a 1. Deriving the z with respect to x, you are deriving x. I mean, z and x will be considered variable. When you reach x, so you are deriving x. The derivative of the x will be the ln y beside. Okay, so it would be
Right.
y. Now, I mean, whenever we have the old scenario, dy over dx. So anytime you see a y, it would be dy over dx. The x would be dx over dx. Okay, so it's only when you reach z, you put z with respect to x. Anyhow, so deriving the x would be only ln y, I wrote. Now deriving the square would be 2z times
2C.
over dx. That's it. So let us collect those on one side, and you keep the rest. I prefer to take this to be minus, so keep it on the left. I want to prefer take that to the other side. So it would be ln y equal, take z over the, x common. It would be 2z minus y. You agree? So
Yes.
for answer, let me write it in a different way. Zx, deriving z with respect to x is zx sub x, would be ln y divided by 2z minus y. That's it. Now let us do the second method, which I prefer because second method is faster. Okay, this method
Okay.
is faster. You would do it one way. That's it. It's only one way. So we know that would be right away because I collected those on one side in f. Right away would be zx equal how much? Minus. We say it is fx over fz. You agree? Always use
Right.
this way. Okay. I mean the way it is written. With respect to x.
And this method, I found it to be more easy. But if they ask us find it implicitly, we can use this method. It's not a
Yeah,
problem.
for sure. Yeah, both implicit, but that using function f scenario. So it in the book it is in I guess 14.5 section, and they call it, for example, let's say equation, or this is like a relation name, whatever. Okay, they won't say like use relation. They may use like approach it through f. They may not ask. So it's either first method or second method. Which way, it's up to you. But I prefer
Okay.
this method. It's faster. Let's do and compare our results. So minus, I would keep. Deriving this, you derive this with respect to x. If you derive this with respect to x, you consider the rest to be constant. So I have this to be 0, that to be 0. I get ln y. You agree?
Right.
So it's ln y right away. Deriving this with respect to z, so I have a y, and I have minus 2z. I'm done. You see, it's the same. So it is a y minus 2z. Now you may ask, I have the minus. The minus right here can be shift either up or down. If I shift the minus down, I would get
CY plus.
y into 2z minus y. So do I have the same answer?
Yes.
Finish. Which one is faster? Now here it needs attention, so be careful. Okay, it needs attention because those pops. If you are unable to pop these, you are lost at some point. But that is easier. This is easier. Okay, any question?
Okay. No, it seems
Okay,
good.
so that was from section 14.3. Okay,
Number
number
50.
50. Okay, next.
76.
Same
Same
section
chapter.
76.
But 76 مش not all of it, only D, E, and F.
Okay, now determine whether Laplace equation. So Laplace equation is uxx plus v yy equals to 0. It's a certain. So you want to derive second derivative. Do you want to derive twice? Twice. Uxx plus uyy equals 0. You want to do EF.
Right.
Okay, I will do the F first because sinh and cosh I wanna just make a review about. Okay, so I wanna list for you the sinh derivative. But first, let me do the second part, which is F. So you wanna ask yourself, is uxx plus uyy equals 0? Yes or no? Okay, if it is,
Yes. Okay.
it satisfies Laplace relation. So let us start. You want to derive ux first, and then ux one more time, okay? You want to derive ux first, so you consider y to be constant in this case. Deriving the e, and this is beside. So I would, by deriving the e is itself, the minus pops out. Any question? Because deriving the minus x would be minus.
Right.
Okay, good. Now, I'm done. Let us shift to the second term. There's a minus in between. Deriving with respect to x, so the e minus y to consider to be, so that I would copy. So minus e power minus y, but deriving the cos is a minus sine x.
Right.
Okay, that's it. Now you wanna get uxx, it means you wanna derive the result again with respect to x. Again, I have the x part right here. So this is considered to be constant in this case. I keep minus cos y. Okay, deriving the e is itself, minus pops again, so this
Plus.
plus, finish. Now deriving the x, so this is a plus already, deriving the sign is a cos. This is constant in that case, under multiplication, stay the same. So that's it. So this is my answer. Now I wanna make sure it would be equal to 0. Do the y, u, y, y. Let's do u, y first. Driving that with respect to y would be, so stop me if you have any question. Driving the cos is a minus sine y. Driving for the y again plus. Okay,
y
one
plus
more.
x.
Derive this one more time. What do you get? Again, derivative of the cos stays. Deriving that is
Minus.
cos stays. Okay, now let's add the white with the green.
Cos x. No, x.
Yeah, because you are deriving with respect to
Big
y.
y.
It's constant.
Right.
Now add the green with the white. Do they cancel? Yes or no? It's exactly they
Yes,
cancel.
they cancel.
So is it a 0? So it satisfies. So you say yes. So verified. Is it is or you want to show? So is it determine whether? Yeah, it is. It is. Okay, verify that it satisfies Laplace equation. Now for the sinh and cosh, that I want to get you to the. Okay, so I left the other part. Now let us solve it now. Okay, now the derivative of the sinh is cosh sinh. That's it. So let me just write derivative of the sinh. Let's say u is cosh u times u prime, chain rule. Derivative of the cosh u is u times u prime. Okay?
Okay.
So we're doing part E. Let's do it fast. Ux first. Deriving with respect to x, so cosh is a constant in this case. I would copy it times cos x. Deriving with respect to x is a minus sine x, so I would take this off. Minus sine x sinh y. Any question? Now you want to derive one more time for x, okay? So this is what you pay attention to. Cos y stays the same. Deriving the cos is a minus sine x. Deriving sine is a cos x. Sinh y stays the same. Okay, that's it. I keep it. Now let's do uy first. You agree? Driving for y, so sine x stays the same. Sine x. Driving the cosh is sinh y. Driving sinh is cosh. Cosine. Okay, so it's easy. Okay, uy. Yeah, let's. Your attention is y. Okay, so
Yeah.
you want to drive those. The ones being to the front stay the same. Driving the sine. It's not sine, sinh. So driving the sinh is and driving the cosh is
Cosine. Sin.
sinh. I want to ask you, is the blue, let's say, with this color, with the white, adds up to 0? Yes or no?
Yes.
Okay.
Yeah.
So
Yeah, it does.
So it does. Okay. So you say we add them up, you get the 0, blah, blah, blah. So it verifies Laplace relation. Any question?
No, it's clear.
I'm done. Okay, next. So choose what else?
هن قالوا لنا انه دي كمان بس it's the same thing. 76D.
What do you mean? Number 76 part D or what?
Yeah, okay. They told us 76 part D is also recommended.
Okay. Section. Which section? Which one is
Section.
yeah.
The 76, same question, number D. U equals ln.
Oh, okay, go on. Okay, we'll do it. Okay.
Same thing.
Yeah, same. If you want to solve it or no, or let's just.
Let's go a little bit.
Okay, go ahead.
I don't understand.
Yes. So let's do. Yeah, go ahead. Follow me. Okay, ux first. Driving this with respect to x. So be careful. Now you have a radical.
Good.
Right?
So x2 plus y2
Yeah,
has to be above 0.
Okay, this can be simplified. There are two ways. Either you keep it or simplify it. For me, I would go on simplifying this look. It would be easier to derive. If you don't simplify it first, you have like complicated forms, or you simplify it later. So for me, I guess maybe you face difficulty because you didn't simplify the look before you go on. So you know that ln radical a is how much? It's ln a power half.
Right.
This is not derivative. This is ln property, we say. This is ln property. Do you agree?
Right.
Simplification step. Now, it is a must, I guess, because if you want to reach second derivative, you will get complicated forms. If you don't simplify, it's not good. So if I want to derive, let me change the look now based on that form. So the u can be written as half ln into x squared plus y squared. Can you? No, because you have ln AB to be simplified. Ln A over B can be simplified, but you cannot simplify ln A plus minus
Plus
B.
B. Yeah.
Okay, perfect. So I want to derive now u with respect to x. Go ahead. So it would be half ln, deriving for the deriving, let me write, deriving the ln A would be how much? A over A. So
right.
half, deriving that with respect to x, you get 2x
2x
itself. Now let us simplify before I derive one more. So the 2 and the 2 cancels. You get x over. Now you want to derive one more time. If you want to derive one more time, so it's better to write x. With respect to x, so this is what? This is quotient. Then you apply quotient rule. Yeah.
Yeah.
Okay, go ahead. Apply quotient rule. So it would be u prime v minus v prime u over
v
v
squared.
squared. So it would be what? Deriving with respect to x. So it is 1 times, I would copy, minus this would be 2x times the x, you get square over the power 2. Okay, now let us simplify it if possible. Yes. So this minus, you get y squared minus x squared, and no more you can do anything. You agree?
Yes.
So let us do now u y y. Again, remind that u is half ln x squared plus y squared. So let's do u y equals. What do you get? Again, half 2y over. Simplify, you get y. The 2's cancelled. Now again, u y to y. You get quotient rule, which is again blah blah blah. So this is pretty simple. Okay, simplify. What do you get? You get x squared minus y squared over. Now I want to ask you, this can be written, by the way, minus out x squared minus, so it would be flipped. I mean flipped.
Yeah.
Why I am writing it this way? Because I want to show you that if you add the yellow with the white, they are the same, exactly the same. This is exactly the same, but there's a minus, there's a plus. So when you add them up,
it gives 0.
So when adding, upon adding, you can write blah, blah, blah. So it satisfies Laplace relation, right? Laplace relation. Okay, next. What else? So I guess 14.3. Do you still have any questions in this?
No, it's all done.
Okay.
Yes. 14.4, number 16.
Number 16. So I go up. I'll go up here. $16.
Yes.
Okay. Yeah. Okay. Read it, please. What do you get? So if you want to do number 6, find the equation of the tangent plane to the surface. Okay. Let us write the rule for. Okay, that's already open. Okay, equation of the tangent. Let us recite the rule and fill in. That's it. So this is, by the way, we have z, x, y. So the formula would be fx, which is the gradient, the partial derivative f with respect to x, into x minus a plus fy into y minus b plus fz z minus c. That's it. This is the equation of the tangent. Do you agree?
Yes.
Equation of the tangent. Equation of tangent plane. Now this is the point. Just to remind, this is the a, b, c. Okay. Now you want to do the partial. We want to form the function f x y z. You don't have the f yet, so that can be pushed. You can push it anywhere, left or right. It's up to you. So I would call f x y z z minus ln x minus 2y. Okay, that's it. Let us do the gradient. I mean, just for the sake of the meaning of gradient would be the normal vector, which are those values. To the values because you want to replace the point at the end. If the point is not given, it would be expression. Okay, so the gradient would be deriving f with respect to x. Go ahead, tell me. So y and z would be constant in this case. So z is 0 in this case, right?
Okay, can you repeat that the gradient is deriving what in respect to what?
Yeah, you are deriving. Okay, so delta f is n, which is equal to fx, fy, fz. Now I want to find fx. Deriving f with respect to x. So this is a 0. You want to look inside. You agree?
Yes.
Deriving the ln is a prime over a. So I want to write x minus 2y. I have a minus at the beginning. Deriving the f. That's it. That's it. I am done. This is fx. Now you want to plug in the point at 3, 1, 0. How much is x?
3.
How much is z?
1.
Plug this in. What do you get? You get minus 1 over 3 minus 2, which is minus 1. Finish. Let's do fy. Fy, you get into the ln. Again, it's minus 1 over, or what? How much deriving the y would be? Minus 2.
Yeah.
Over x minus 2y. So the bottom is the same, by the way. 2 over 1. Okay, let's do fz now. Fz deriving with respect to z. I don't have z here, so it's 0. Okay, so it's only 1. That's it. So the equation of the tangent, let me copy this guy. This. Yeah. And copy. That's it. You want to replace those numbers, minus 1 to 1.
And we just plug in.
Yeah, just plug in. So by the way, you should simplify, completely to get full mark. Your exam is full solution, is it?
Yeah, it's no solution. It's
no solution. So yeah, to get mark,
it's only show solution in the last question.
The last. Okay,
yeah,
so
it's like the midterm.
Okay, yeah. So that you would fill in. I mean the solution, right?
Yeah.
Okay, in this case, yeah, it's better because Moodle, be careful. So be careful when they say use decimal, like half is rejected, so it should be 0.5.
Okay.
Remember that mistake. So be careful right here, you should simplify it. I mean, let us put delta f. So put conclusion. Delta f is how much? You take minus 1, 2, 1. You agree?
Yes.
Minus 2, minus 1, 2, 1. Okay, so replace those again, minus 1, 2, 1, and fill in the rest. So what is your point? At 310. At 310. So final answer would be x minus 3, you know, y minus 1. It's there's no trick. The trick would be like some minuses here. I don't see, right?
Yeah.
Question. So that don't leave because you want to simplify. So they expect you like to get it in standard form, minus x plus 3, and this is simple. And yeah, we'll collect constant on one side. So you get minus x plus 2y plus z, kick 3 minus 2, which is a 1, minus 1. And that's it. Okay, you can minus more, but this is the equation of
The tangent.
equation of the tangent is the equation of tangent plane. Yeah, what else?
Number 16.
Yeah, number 16. Okay, explain why the is differentiable. Differentiable means when you derive and you plug in the point, it exists. Okay, and then find the L function. So
Differentiable means when you plug in the points it exists.
no, when you plug it in the derivative.
Oh.
Okay, so be careful. The question, there's a little tricks right here. The question may be this way. Let's say continuity for the function to be continuous. Continuous means the limit of the given function exists. Limit of at the say exists to be continuous. Okay.
Okay.
Differentiable. It's like the limit of the derivative at the point. Okay, exists. So the derivative at 0, 3 exists. Okay, it exists. Good.
Yes.
But by the way, differentiable, when the function is differentiable at the point, it means continuous. Continuous does not mean differentiable. That you should put in mind. They may ask you some parts or based on this, so what? It's a theory and even like a fact. You agree? It's a theory.
Yes.
Differentiable means continuous, but continuous does not mean differentiable. Anyhow, so your question is it differentiable or show it is differentiable? Differentiable means delta f exists, by the way, because partial derivatives mean delta f.
That's right.
This at 0, 3. This is what you should prove. So let us go on. Fx is how much? X is 0, because I don't have an x in that. Deriving the sign is cos. Now for the x, the one to the front remains, which is 1 over y. Chain rule. You agree?
Yes.
Okay, let's do now fy. Deriving with respect to y, this is a 1.
Right.
Okay, deriving sign again is cos, but for the
X.
it is no
X.
at the bottom. Let me make it clear. Deriving y is y prime. Deriving 1 over y is minus 1 over y squared. Why? Because when you push y, because 1 over y is y power minus 1. When you derive it, you get minus 2 as a exponent. Do you agree?
Yeah. So x over.
Where is y? Is it up or down?
It's down. So
down.
x
So
over
you follow
y
this.
to the power.
So the derivative would be that. It's not so x would remain times x to the front, but multiplied by minus 1. So this is what it pops. Do you agree?
Yes.
Now at the point, let us plug in 0, 3, by the way. If you plug in 0, 3, this is the 1, so you get 1 over 3. Okay? Again, this is cos 0 is a 1. This is cos 0 is a 1. So this is 1. X is a 0, so that goes away. You agree?
Yes.
So what is delta f? I mean, delta f is fx, fy. This is a vector for sure. So it exists. So it is it means differentiable. Finish.
Okay. What would have we got if it didn't exist? She over 0.
Like 1 over 0. So if you get no numbers, you get infinity in that case. If let's say delta f turns out to be undefined at some value or at some point, if delta f, let's say fx is a 1 over 0, so this doesn't exist. We say it doesn't exist. Yeah, you may have it. You know how? If they change the point, let me make clear. Example: if the point was reversed, reverse this point. 0, 3, make it 3, 0. If you make it 3, 0, okay, go up.
0 بتصير تحت.
So yeah, so 0 at the bottom, then it is undefined. So this is a case differentiable. So example, if the point was real, then I would say delta is not differentiable. By the way, not differentiable. So let me write it properly. Is not differentiable means non-differentiable. Not differentiable means non-differentiable. So you may have a question, by the way, show it is non-differentiable. Okay, it means you end by either one of those partial derivatives of x or fy to be undefined. Any question?
No.
Within the question. So explain why the function is differentiable. We did. Then find what do you want to?
The linearization Lxy of the function at the point.
Yes. Okay. Now let us write the L function scenario. This is two-dimensional, right? Because
Right.
L function as well. By the way, L function is similar to the as a relation. So let us write the L function. The L function or at a point xy is this. It is f of xy by, it is f prime, let us write it, x minus a plus fy, right?
Yes.
Let me write it properly. So plus f of f prime x minus a plus how much?
Plus
So this is when it is in plane, but we are talking about partials. It should be what? Lxy would be fx for x minus a plus fy y minus b plus f of xy.
f of x.
That's it. This is the relation. You can refer to the theorem, and this is the formula that you want to write. Do you agree? But it's exactly the equation of tangent. That's it. Do you have fx, fy? Yes, we before. Fx, fy are those obtained.
Yes.
1/3 and 1. So just I want to plug in and you continue. This is 1/3, blah, 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 and this is a 1. And the fxy we would find. What is the point? 0, 3, right?
Right.
I flip it right here, but it was 0, 3 up. Okay. Now let us at 0, 3 that we didn't. X0, so this is bye-bye, and that would be 3. So fxy is a 3. You agree? This
I
is
say fxy. How did we get it to be a 3?
just plug in the point. That's it. Plug this.
Okay. So fxy is just.
Yeah, sine 0 is a 0. You get a y, which is a 3. That's it. So this is your equation. You can simplify it. That's it. I mean, they expect it to write 1/3 x plus y minus 3 cancels. So this is my L function. I am done. Next. This is here, and that you get in. Is it clear?
Yes, it's clear. Number 26.
Same lesson.
Same lesson.
26. I'm here. 26. Okay, find the differential of the function. Find the differential, it means the derivatives.
Right.
The differential of the function. Now they say differential because differentials are right here with respect to x, with respect to y. It means that you want to find your gradient.
Okay.
Okay. Let me point to the lesson. Go. So this is what you want to refer to as differentials. Okay. Your
Okay.
be in the look of dx dy. So differentials is exactly the gradient, but with respect to x and dy, clarified or explicit, written explicit. So this is, we call it differential. So let us apply it. That is for number. We go back.
Number 26.
26.
This one level top.
Yeah, that's right. We'll copy it. Okay, so the differential would be here du. So the du would be equal to fx dx plus fy dy. Okay, in this case, this is my f. Or you can say, if it is written in a proper way, because it's a u, I would say du equal ux dx plus uy dy. Okay, that's it. Anyhow, so those, by the way, are fixed. This is the look of the differential.
It's not a term.
Yeah, they are not values. I mean, unless it's given x changes from, as in example 4. Okay, so you refer to. If x is given from 2, then delta x would be determined. If y changes or varies from this and that, then the dy has a value. But in this example, it would be letters. Anyhow, let us find it's a radical part, so deriving the radical is how much? Properly, it should be a prime over 2 root a. Do you agree?
Right.
I mean, average students would write this as a power half, and deriving that would be half a power minus half, which I don't prefer because this would be a radical in the denominator. We don't prefer. Yeah. So above average students should write that as reference for the derivative of square root of a. Good.
Good.
So derive properly. Deriving with respect to x, it would be 2x over itself. The x will here. Deriving this with respect to y would be 6y over 2 root itself. I am done. Just simplify a little. I mean, just take off the 2's, and this is 6 over 2 is a 3, and you're done. Any question? That's it. I am done. This is the look of the differential, du. That's it.
Okay.
That was lesson 14.5.
Yeah, 14.5. That.
Okay.
No, it was 14.4. Sorry.
14.4. Okay.
Okay. Hello, 14.5. Number 8.
Okay. Chain rule. You want to make a tree. Number 8. Okay. So use chain rule to find. Let us make it zoom in. Z, number 8, ZS, ZT. So let me pick the question even. Okay, have you attempted this problem or no? Have you tried?
No, I didn't attempt it.
You didn't attempt? Okay, so we'll solve it together, let's see. Okay, go ahead. So you want to find ZX, ZT. Yeah, I supposed to abbreviate it as ZS. Z is in terms of x, y, x in terms, y in terms. So we say applying, before you apply chain rule, you want to do the tree. We say tree derivative, okay?
Yeah.
So we make a tree. The tree would be z based on x and y, and the x itself based on s and t. Okay, this is the plan, I mean. Y is based on s and t. So if you want to find, we say zs. If I want to find z till s, should pass by x and then pass by s, by x. If you want to go from z to s, pass by y, and then you want to pass by y and then to reach s. You get it? Now each path you multiply and you add the paths. If you have many paths, you do so. This is what we call chain. This is the chain rule of derivatives. Okay? So zs, let us write it in letters. So zs would be z times xs, okay, plus zy times ys. That's it. Okay, now you jump right here. I mean, zx and zy are fixed.
Yes.
And we want to use them next in the next step, which is zt. Anyhow, deriving the z with respect to x, it's tan inverse. Tan inverse u would be how much? Let us state the rule: u prime over 1 plus u squared.
Right.
And that's it. Deriving the ln u would be, because I have a ln, it's u prime over u. Deriving the e to the u. I'm listing rules within the problem, right? I have tan inverse, I have ln, I have e.
Yeah.
So deriving the e would be eu times u prime. So if you know those in blue, you are the orange part. Okay, let's fill in. Deriving z with respect to x. So tell me, derivative inside is for x is 2x.
Right.
By 1 plus all squared.
x2 plus y2.
Finish. Okay. Times x. I jump to x. I want to derive this with respect to s. So s, you consider ln t to be constant in that case because it's wrong.
Yeah. So just ln t.
Ln t. Finish. Plus. Now jump to the y. Again, it is the derivative inside to y over 1 plus again. times derivative of the y with respect to s. So this is es, right? T is a constant to the front, so t stays. Okay, t stays multiplied by es is itself.
Yes.
That is a weird relation, and even you don't have any point. Be careful. If they say use chain rule to find this at a point, so the point would be x, y, z. This will, yeah, you have many questions. But then you have to replace those in. You have x, y. You don't have x, y, z. You don't have x, y, z. The point should be in this case at st value, for example, or at st. They give you, for example, st values. You plug them in. When you plug in st, you get the xy. You get it?
Right, to get the z, we plug in xy.
Yeah, but you don't have any points. So this is your relation. You cannot simplify even. This is weird relation. Anyhow, you stop. That is. Now you want to do zt, you do the same. So I won't do it. Okay, you can do it. zt would be just say zt to reach t you pass by x. So zx times xt plus zy times yt. So by the way, zx and zy are the same. Okay, those won't change. You agree?
Right.
Okay, so let us find x, xt, yt. So those are the same. So how much is xt? Deriving x with respect to t, it's a ln. S stays the same, so it is 1 over t. Any question?
No.
Deriving y with respect to t, so es is constant in this case.
Constant وt بتروح.
That's it. So you multiply this expression by s1 over t, blah, blah, blah. Next, any question? Is it clear?
Yes, it's clear.
I'm moving
So-
fast. No, I mean, your level is average and more, above average. So
No, it's okay. It's not that fast. The thing is, when they ask us in the exam to find z over s or z over t, we just do this.
yeah, sure. It depends on the given. I mean, if z right away, imagine z was s ln t. You want to do in this case zs. I mean, zs simply ln t. Finish. You are done.
Right.
So that would be easy question. For that reason, they do z in terms of x, y, x in terms of blah, blah, blah. This is the whole lesson, what is all about. I mean, it's about chain. It's a
Yeah.
chain, 1, 3. Okay?
All right.
So the 3 are lost. Be careful. Perfect. Unless you are A+ student. A+ student or a professor will do it right away. I see it. I can see it. I mean, z what? zs. So I don't see s. In z, I don't see s. I see x.
Yeah.
But I see x and s. I mean, if you are above average, like A+ student, you can do it without a 3. But I mean, you should show solution in case they ask you to do it, even not to be lost. So this is your reference, how you derive. I mean, when you write this relation, easy to derive. Any question on the derivative?
No. في بعد number 12 اللي هو the same thing.
Yeah, we can do it. Same scenario. They say z. Let us pick first. Z what? Number 12 in this part. Okay. So it's zs zt. Yeah, zs zt. Perfect.
Yeah.
We have more letters here. I mean, or different letters. zs zt again. So let us do the 3 first.
Yep.
Okay, so let me make it clear. The question is find zs zt. Okay, so we say build the tree. Okay, go ahead. What shall I do? What
Z or
I mean,
Z
it's easy. I mean, the concept is easy. You say z. What letters do you see in z? It's u. So z depends a function in u and v.
Right.
But I see u a function in s and t.
C.
If I don't see t, it's only in s. Okay.
Right.
That's it. S and t, and v is again an s and t. So now I want to find zs. So I would say zs, z to s. I should pass by u to reach from z to s.
So ZU.
I have a plus in between always. Okay.
Yeah. So
And in
ZU.
every path you multiply.
Oh.
So yeah, go ahead. Recite.
ZU times ZS.
No, zu when you from u. ZU times U S. Be careful. I want to get to S. If you put ZU and you said what? You said Z again? This is not true, okay? Be careful. You cannot say ZZ. And when I reach ZU, I continue US.
Okay, so
figure out.
plus ZU plus
Okay.
plus ZYYS.
Oh, good. Yeah, ZYYS. It's written here even. You have the same tree. I mean, when I reach X, I want to get to S. So the path is only through X. You cannot jump to S. Can you jump to S without X? Can you jump to S without Y? You cannot. So this is the path. Any question? So why did you say ZU, Z something? This is not true, okay? ZU, I didn't reach S because I want to get Z with respect to S. So to reach S, you want to continue. ZU, US. You agree?
Yes.
Plus. Continue. I have another path.
Yeah, ZVVS.
Okay,
VT,
perfect.
sorry.
That's it. So all you have to do, just let us find each. Now the Z jump to the Z, you have tangent. So let us list the rules. I mean, what is the derivative of a tangent U? It is U prime secant square U. You agree?
Yeah.
Okay, and the rest are linear. This is so easy. There you don't have exponential, you don't have ln, you don't have radical. Okay, those are, you don't have any trigo in this even. So ZU is derivative of the tangent secant square, what you see inside. Now you want to derive with respect to U, so it's a 1, but
1 over V.
1 over V, finish. This is Z only, times, let me put this in the white. VS or US, this is US. ZU US, this is U. Okay, U with respect to X is 2. I am done. Let us do the Z with respect to V, again, secant square, what you see. Deriving with respect to V, V at the bottom, it's minus 1 over V square. I have U beside. Any question?
No.
Okay, times VS is a 3. That cannot be simplified, leave it. That's it. This is ZS. Finish. Let us do now ZT. Is it clear? Do ZT as if Z to T. I say
ZT, ZU
times
UT.
Sorry? Times?
UT.
Good. So reach you continue. Okay.
Plus ZV.
V times?
VT.
VT, perfect. Okay. Now ZU, ZV are the same as before. I mean, so let me make a circle. This is exactly ZU, right?
Right.
And this is exactly ZV. It's so easy. So it's only you have to put the same, okay, dots. Okay, so how much is UT? Go up, and it's so linear.
Yeah, it's 3.
And V with respect to T is minus 2 100 times. I mean, all time. Any question?
Oh no, it's all good.
Okay, next.
Just 1 second. Times minus 3 آخر شيء. Minus 2.
Which one?
Number 2. هلا اللي كنا عم نعملها the last.
Yeah.
Minus 2.
I mean, you put those in circles beside and 3 minus 2. I mean, you cannot simplify. That is the look. Finish. You just stop right here.
Number 34.
34.
Use equation 7.
Okay, so what is equation 7? Equation 7. This is equation 7. This is the implicit we talked about. So if I want to do again ZX, it means FX, FZ. You see, it's like a cross way.
It's the same equation to use in the above shot.
And the implicit. That's it. Okay, so 34, we did it, by the way. We did it exactly. If you want to choose other, let us choose 33.
Yeah, 33.
Because that is exactly, we did it in 2 ways, okay?
Yeah.
33, I want to find ZX, ZY, huh? So go ahead. It's your turn. Do it. So let us say find ZX
and ZY.
With respect to X. So it can be written ZX, and find delta Z with respect to Y. It can be written ZY. Now let us. They say use equation 7. Use equation 7 So it means I want to use, which I would prefer always, so that you want to build your function. I don't see a function, right? So you take it either left, right. So this is easy. You say fxyz is the log ez minus xyz. Do you agree?
Yes.
Okay, use equation 7. It means how much would be zx now? Equal minus. Recite. What do you say?
Minus.
What shall I write? F. Now you want to write f. F what? F.
Yeah, f prime.
Yeah, f what? F.
F yo, fz.
Fx.
Fx.
Always this up, that is down.
No, okay.
Fx.
Fz.
If you recite it improper, it would be wrong. Okay, so be careful, just to make sure it's written here. Fx, okay, Fx, Fz. Now f big, f small doesn't matter. It's the function that you call it. You agree?
Yes.
Okay. So let us do it. It's so fast, I mean, and easy. Now this is if you want to derive this with respect to x. So easy is a 0. Deriving with respect to x, those would be to the front, so it would be minus yz. Is it clear?
Yes.
I mean, it's so simple. Okay, fz, deriving with respect to z, az would be the same, times 1. And deriving with respect to z, it would be minus xy. Minus xy. Do you agree?
Yes.
I am done. You cannot simplify. Can you take any
No,
left
you can't.
off? That's it. You cannot
The
do
only thing you might do is the two minuses.
Yeah, perfect. The two minuses. So yeah, you can say it's a plus and that's it. So let me write. It is a plus yz over ez minus xy. Let's do now zy. Okay, so zy.
Zy equal minus y over fz.
Okay, finish. Okay, now f small big, it's the function what you call. Okay, you want to call it big F, big F. So tell me, fy is how much? Deriving this with respect to y is how much?
Ez minus.
Ez no more. Ez has
Ez.
no y.
Right. Minus y.
Deriving this with respect to y.
Minus 1.
Minus 1 what?
Uh,
Wait, ez has no y, so this is 0.
yeah.
Deriving with respect to y, if I have 3y, derivative would be 3, is it? Deriving this with respect to y.
Minus xz.
Minus xz, okay, good. Why you hesitated before?
Because
Why you didn't see it before?
the
You said
yards.
1. You said 1, yeah, 1 for this, but xz are, so they stay.
Constant.
Wait, so be careful. Yeah, constant under multiplication. So what shall I write? Minus?
Minus xz.
Okay, perfect. There is, fz is the same, okay? Copy it. Just
yeah, fz is the same.
So minus again xz over ez minus x. Any question?
No, it's all good.
So this is all about. That's it. You are done. What else? 14.5. Do you still have any question?
Number it's the same thing, I think. No, it's not the same thing. Number 46.
46. Okay. 46 fz where x blah blah blah. Yeah, same. It's longer in a sense. 46 of. You want to show that this relation hold on. Well, I can start by. It's so easy. I mean, but it's long in a sense. Make big letters. So 46. Okay. Is it clear, SNT?
Yeah.
No, you won't have this in the exam. It's so long, by the way. This you won't have, but it's good to get the concept, right?
Yeah.
You wanna even if it comes, it means maybe this is the question to show steps, right?
Right.
Because your questions are a fill in or A, B, C, D till the last show solution. Anyhow, everything is clear. U is in X, Y, and X. So this is a chain rule tree derivative. Okay, so let us do the tree. U in function in X and Y. Okay. X based on S and T. This is S, right? U based on S and T. Y based on S and T. So they ask you show this relation. So what do I see right here is ux. Let me write it properly. Ux squared plus uy squared b blah blah blah. So let us find this left side, and then you see if they match. Is it? So that don't touch, by the way, because I mean on the left you should find something and it should match. If it doesn't match, simplify it to let it through. Okay.
Okay.
So let us do it. It doesn't take that much. I mean, so let's do.
ux.
How much is ux? Ux is so direct.
Yeah.
But you have here us. For you to reach s, you want to do ux xt.
xs.
Must. So it's a must. You cannot match unless you find the left side and you want to find the. So yeah, this is why it is long. Okay. I mean, when you do the left side, it doesn't. You cannot see it properly unless you find those values.
That's right.
Anyhow, the left is easy fast. What is ux?
uxxs plus uxxs plus uxxt.
A function xy, right?
Yeah.
Where x is okay. So ux is fx. Yeah, but a function in x. Yeah, but the function. This is weird. Function is not given. I mean, what do you expect as a student? You expect to have u equals something in x. Let's say 3x simply plus 5y. Let's say. Or I mean, harder than this. Let's say it is 3e to the x. Let's say plus 5 tangent y, for example. 5 ln y. You get it?
Yeah.
You expect u explicit. It's not a letter. I mean, what they said, this is fxy, and they didn't say what is fxy explicitly.
Yeah.
They just put letter name for the function. So what do you expect to do? I mean, I don't have something to derive. If it is something I see, I can derive it. Can you derive f? You should keep it in a letter name. This is the whole story. You want to keep this in letter name. Do you agree?
Yes.
I mean, now, and if this is u equal f, so what is ux? It is fx.
Right.
Ux is fx. I don't
ux
have
is
it. So what is ux? Ux is fx. Okay. You want to square it later. So I want to find ux squared. It means f square x, if you want to write it this way. You agree? I cannot do any more. Okay.
I didn't really understand why ux is fx.
Because there's nothing to derive explicit. This is not. This is general. I mean, what they put is general. Do you agree? So uy of f5, it means uy squared is f square y. Okay, I want to ask you. This is so simple. If y equal f of x, how much is y prime? F prime. That's it. Which is dy over dx. Do you agree?
Yes.
This is what? Well, this is the rule. So this is exactly what I am writing. What is your fx? What do I mean by x? It's the derivative of u with respect to x. Maybe you are confused about those abbreviations. So what is ux? It is delta u or du over delta dx. What is fx? It is df over dx. So it is the rule. There's nothing. We have something to derive? No, we don't have explicit. We don't have what is f. You agree? Is it clear?
Yes.
Anyhow, so I see the whole story is in the right side. Do you want to continue till 11 or maybe 15 minutes more? We'll continue this, right?
Yeah,
so
15,
the whole story is in
minutes.
this. The whole story is in that. So let us find US and UT. So US would be UXXT. So let us write it. I want to see it even. So I find those. How much is US? Again, the tree is U. Again, the tree is U in X, Y, ST, in ST. Do you agree?
Yes.
Okay, so how much is US? This is the whole story. US would be
UXXS.
X times XS plus UY times
YS.
YS. So go ahead. This is your reference right here. Okay. Okay, go on. Ux, we said it is fx. Nothing can be written. Xs, how much?
XS is
E to the cos t.
yeah.
Okay, uy is fy. What is ys?
ES sin t.
Sin t. That's it. You cannot do anything else. Now, wow, it's so square it later. You want to square this?
Yes,
Let us square. This is yeah, above average level. Okay, u square of s is squaring. Let us square it. Square plus. So this is the background. A plus b squared is how much? Square plus b
A
squared.
squared plus 2ab.
Go ahead. Let us square. All this is my a, huh?
Yeah.
Square. What do you get? You get f square as e2s cos square t
T, right.
plus f square y e2s. You see the s. I don't like to put it that way. It may be like pi. I would indicate this is s. Okay, sine square t. Good. Plus, what is left? 2 fx fy. I multiply e. Es is how much? E to s cos times sine. Do you agree?
Right.
It's definitely above average levels problem. Okay, keep it. Let's do now what ut now, and then square it. So again, we'll do the same. How much is ut? Again, the same thing, but in t. So
yeah.
it is
ux xt
ux xt
plus uy yt.
plus uy yt. Okay, so go on. Let us shift. I should see the relation, and I should see this. Okay, go ahead. So how much is ut? So ut would be ux again is fx. Xt is how much with us? So the rate of the cos, it's minus es sine t. You agree?
Yes.
Deriving now, I'm here. Uy, how much is uy? Fy. Yt, the rate of the sine cos. So es cos t. Let us square it. Go on, square it. Get the square in.
Yeah, fx squared.
The minus goes away, okay? E to s. Right. When you square, you multiply exponent. Okay, tell me if there's any question. What shall I write? Now I have a minus, huh? So it would be minus. It would be minus.
Yeah.
2 fx fy e power 2s. There would be simplification. This is the whole problem about sine t cos t. I am done. Now let us figure out the relation. Those up. So which one I want to add? I want to add all this to which one?
To the one above.
Okay, let me copy it. This is what's good about digital study. You can see it properly now. I want to put it to the below. You would see it exactly. Okay, so I want to add the red with the white, this to the violet. Add those up. Okay, which one remains? This would cancel. Do you agree?
Yes.
All this would cancel. Do you agree?
Yes.
Okay, now for the one who's reviewing, let us see. So this would cancel. Okay, what else it remains? Those are the same. So be careful. If you want to add those up, you take f squared x with e to x common. What remains in is sine squared t plus cos squared t. Do you agree?
Yes.
Okay, if you add those up, how do you add those up? You cannot leave them this way because I have common. What is common? I have f squared y e power 2s. Again, you take common, you get x squared plus sine squared. Do you agree?
Yes.
Okay, this is the answer of the right side. You can simplify more. What is the more that you can do? Well, how much is sine squared plus cos squared? This is a 1, right?
Right. And this one is a 1 also.
Answer would be, I would say, the right side. So this is the right side, huh? The right side, but be careful, the right side has minus 2s to the front. So the right side, the e power minus 2s to the front. Okay? You agree?
Yes.
Okay. What shall I write in? F square x e power 2s plus f square y e power 2s. Simplify more, get this in. e power, what do you do with the e's? You add them up, you get e power 0, which is a 1. So your answer would be how much? Tell me.
fx, fx.
You know from where did I get this? It is from the right side, huh?
Yeah.
Any questions? So far, so good.
No, so far so good.
Okay, perfect. So tell me the final answer.
The final answer is
F square x.
e2s.
No more e. E and e's. You add them up, you get e power 0, which is a 1. Finish.
Plus f2y.
Plus f square y. And that's it. So this is the right side. Okay, let us go to where do we started. Where's the left side? Let me make it clear. The left side, we are here. Where's the left side? This is the left side. Where's the left side?
Here. ut2.
Well, we are the left side. us. You want to go to ux. You want to go to you want to find ux. No, this is us. We wrote it. We started up. Right? Here.
Right.
So left, I should write left side. Your left side is this. U square plus U square. So this is ux. Okay, U squared, U squared. So those are, we didn't add. Did we add on the left?
No, but it's the same. تطلع نفس الشيء f2x plus f2y.
So just I want to write the left side is the addition of those two. So I would get f square x. I didn't write it. That's it. So they match. Okay, so we say the left side is identical, okay, or equivalent or equal. Left side is equal or matches, is equal to the right side.
Right. Yeah.
So we have
that's true.
So the whole story, maybe the whole story is, be careful. So I want to just put a note because, but maybe the start that makes the confusion. If u is not explicit, what do I mean explicit? Like u, not in terms of ln, tangent, radical. It's not something. It's not an expression. If u is not explicit, then u would be a function which is we don't know. Then ux would be fx, and then uy if fy. If you don't write this at the beginning, if you are unaware of this relation, then you are lost. You can't figure out what's going on. Is it clear?
Yes.
Okay.
All right.
Perfect. So
perfect.
do you have any more questions or?
No, it's all good.